Hello guys, welcome back to my channel Memo African Motives. Still working on engineering science N3. In this platform we are going to be focusing on the question paper, which was actually it was April 2019. We are working on moments. So if you're new to my channel, you can consider subscribing so that you won't miss any of the classes that we shall be having from Memo African Motives. Okay, so let us quickly rush through the question we are given on 2.1 to define the moment of a force. Okay, so the question is directly asking you to define the moment of a force. So as usual guys, I always bring you a formula that is in association with the department. So the moment of a force, it is the product of the perpendicular force and the distance of the force from the fulcrum. Okay, so this is an A here, the distance of the force from the fulcrum. So remember this definition I've been talking about this definition for a long time. Anyways, all right, then the other question we are given, actually we are given fig 2 shows the shear force diagram. Okay, so we're given this, this is your fig 2, okay, your shear force diagram with a light beam, or which is A, B, C, D, E with uniform cross section. All the values of the loads are in kilonewtons. All right, so this is the information that we are given there, and the first part is at which two positions in the beam supported, and what is the magnitude of each support. All right, take note about the question guys that you are given. Here we are given the shear force diagram, and the question is asking us a condition of two positions. Take note, two positions. Is the beam supported? And what is the magnitude of each support? So this is the question there. We need to know the positions and the magnitude of each support. How am I going to do this? All right, I want you to relate back guys to this condition. Remember, these are the supports. You are going to be having supports like this, and always the supports, they are facing upwards, which means they are positive, and all the other forces are going to be facing downwards, and they are going to be carrying negative. Meaning to say, a support, for you to locate a support, you are supposed to locate a condition where on the shear force diagram you are going upwards. Always when you are going upwards, that is a representation of what? Of the supports. Why? Because all the other forces, they'll be going downwards. Okay, so let us locate using this condition. I want us to start with A here. If you are to cross check at this point, that's S0 here. If this point is a support, which means you're supposed to go upwards, like I was saying here. So as you can see, from this point we are going upwards. If it was going downwards, it means it's a force just like these other forces, but this one, it's going upwards. And this point, sorry, these values, they're actually indicated. This value here is supposed to be corresponding here with A. It's just the way that they wrote it. This value here is the one that is at A. So which means A is a support. Why? Because it is going upwards. If it was going downwards, it is not a support. Okay, so we have got a support at A, and what is the magnitude of each support? Okay, so at A here is 24,313 kilonewton. Okay, which is 24,313 kilonewtons. Okay, so that is the value of A. And what is another support? Okay, if you move on to B here, it is going downwards, so it is not a support. Okay, we move here, if we got a certain distance, we moved downwards, it's not a support because it's facing downwards. Okay, we moved again to this point, then as you can see, from this point we have to go upwards. It's not going this direction downwards, it's now upwards to this point, then downwards. So as you can see here, from this point here to this point, we are going upwards. So that means at this point D, we are having a support, because we said always the supports, they are going upwards, they are carrying positives. So which means they are going upwards. Okay, so which means there is a support at point D. All right, so that is what we had. And The question now is, what is the magnitude? So what is going to be the magnitude? Guys, I want you not to confuse this. Remember, when you are drawing a shear force diagram, these forces that you are seeing here are the values that are corresponding to points at this point, at this point, at this point. So take note, according to the diagram, it wasn't clear. This minus 5,687, it at this point. This minus 19,687, it is at this point here, not where it is at this point here. This point is the same as this point because it's a straight line. So this force here is the one that is here. This minus 5 is here. So take note, it's not indicated well, but you're supposed to know this one part. Okay, so from this point up to this point, what is the magnitude of this force? How am I going to determine it? This is not the actual force at D, but the difference between these two forces is the force that is going to appear at point D, at the support D. Why? Because when you were drawing this, when you were indicating the shear force diagram, you had a force that you had, then you added in order for you to obtain this force. So now you're going to subtract. Remember, guys, how I drew the shear force diagram from our previous classes. So this time you're going to subtract. So it's going to be 30 minus this force here, which is minus 34,687. All right, so this is what you're going to do. So it's minus there. So if you combine properly, you're going to obtain 64. That's 64. Yeah, 64,687 like this kilonewtons. This is what you're going to obtain. So that is the support, the force that is corresponding with the support at what? At D. Okay, so these are the two supports that we had. In another part, we are asked now to calculate the magnitude of the distributed loads between A, B, and CD. Okay, so as you can see from A, B, C, and this point C, and these are distributed. Remember how you represented distributed when we were drawing shear force diagrams? We used to represent like this. And when we were indicating like this, how did we indicate? We were indicating the force that is between, we multiplied, if there was a force, maybe let's just say F kilonewton per meter, you multiply by the distance in order for you to subtract the force. So this time, since you had to divide, like you are dividing by the force that you have in this case, so now how am I going to indicate? Like, because I subtracted to obtain the value, so I'm going to do the same here. I'm going to subtract between these two forces, because at A, this is the magnitude at A, the magnitude at B, so I'm going to subtract the two. Okay, so that means at A, B, I'm going to subtract the one at A minus the one at B. So it's 24 comma this one minus this one, 24 comma 313 minus 14,313 like this. But remember that you multiplied before in order for you to obtain the what, the force that you had to subtract here. So now you are going not to multiply but to divide by the distance. You multiplied, remember it was force times the distance of 2 meters, but now you are not going to do that. You are going to divide so that you obtain the actual force per meter, because you want the force that is required per meter. So you're going to divide by 2 by the distance. So everything you divide by 2. All right, so that means at A, B, if you divide properly, guys, you're going to obtain something like 5. Remember, these are kilonewton, so it's 5 kilonewton per meter. All right, so that is what is going to happen between A and B. We have got 5 kilonewton per meter. Let's move on to C and D. So you do the same at C and D. What are you going to do? You're going to subtract, find the difference between these two. Okay, so you just find the difference between these two. So it's this minus 19 minus this one, minus 19,687 minus this other force, which is minus 34,687 like this. Everything over the distance, because before you had to multiply by the distance which corresponds between C and D, which is the distance of 3. So before you multiplied, now you're going to divide. So you divide by the distance, okay? So if you do this properly on your calculator, you must obtain 5 kilonewton per meter again. So these two were giving us same answers anyways, but it doesn't mean that is what you're supposed to have in exam always, that they're going to be the same. No, it is only for this condition, okay? And then the other question on 2.23 was to draw the light beam A, B, C, D, E, indicating all value, loads, and supports at the correct positions. All right, and you've got a total of 12 marks for everything. All right. So how are we going to represent the light horizontal beam? All right, we are given the distances before here. The distances between the points are already given, so it's an advantage that you have. So what are you going to do? Just draw a line, a normal line, guys, remember. All right, let's say this is what we are having in this case. And we have got, remember we said A is a support. From the first part we said A is a support, and we always know that a support is facing upwards, and this support is if you are to cross check, this support here is at the end, at the left end, direct at the left end, because it's starting by going upwards, so it's a direct at the left end, okay? So at the left end we've got a support here, indicate this is a support, all right, which is at point A. And we say the force there at A, remember the force that we wrote at A here. All right, this force that we wrote at A is the one that you're going to write at that position, which is 24,313 kilonewtons. Okay, that is what we had at the point A. All right, then what is happening? Let's come back here. From A to B, there's a distributed load which is after 2 meters. Okay, so let's indicate the distance first. Distance of 2 meters. So let's just say this is from A to B here. Okay, so there's going to be a distributed load here in between these 2 points, which is 5 kilonewtons, because we calculated this before. We obtained 5 kilonewton, okay, between this distance of 2 meters. So in between here, we've got a distance of 2 meters, okay. And the distributed one of 5 kilonewton per meter. So we've got 5 kilonewton per meter. Or you can indicate like this. You can leave that distributed thing and write it like this. You're going to divide it into 2, where you've got 1 meter and 1 meter here. But once you divide into 2 like this, you're going to multiply 2 times 5. You obtain 10. So it will be 10 kilonewton like this. But if you use as a distributed like this, you're not going to indicate as a straight line. No, you're just going to indicate an arrow to show that the distributed is between these 2 points, okay? Then what actually happened here? From this point, we are now direct at B. So at point B, as you can see, B is going downwards. It's not, this is not a support, it's going downwards. So which means we shall have a force after these 2 meters direct. At this point, there's a force which is going downwards. All right, at this point B here, something like this. All right, so this is direct to the point B, which is going downwards at B here. So what is going to be this force at B? You are just going to find the difference, because at B you have got 14,313. At this point you have got minus 5,6. So you find the difference between the two, so that you know, guys, it's like this. Do not confuse this part. It's like this. It's like, let's say this point is 3 and this point is 1. How do you find the difference between these two? How do you find the height of this line? Let's say this is 3 centimeters and 1 centimeter. You subtract 3 minus 1, which is 2 centimeters. Okay, so the same thing, this is what you're going to do. You subtract 14 minus this value. Okay, so when you subtract these two, you are going to obtain 20 there. You're going to obtain 20. Okay, use your calculator. 14 this, you're subtracting 14,313 minus 5,687. You subtract this one, so you're going to, it's minus, sorry, it's a minus here, because this one is a minus. Okay, so it's going to be minus, okay, which is going to give us a 20 there. So which means at this point we have got 20 kilonewtons. All right, that's at point B. Then from B, as you can see, there's a distance between B and C. There's a distance of 3 meters. Okay, so there's a distance of 3 meters. You can indicate even on top or even downwards, no problem. 3 meters like this. And C, to find the magnitude of that one, we are going to do the same. We subtract this one minus this one. You find the difference between the two. All right, so in order for you not to confuse these guys, ignore these signs. Okay, just ignore the signs that you are having in this case. You just ignore the signs, you subtract your numbers properly. Okay, but in this case you're going to have minus, this is your upper value, this value here at this point is this minus 5. Remember what I told you guys, this is a horizontal line like this, so this value and this value are the same. Okay, so it's like this. Let me write it. It's minus 5,687, just like what we did, the maximum value minus the minimum value. Okay, minus the minimum value, which is minus 19,687. You won't go wrong once you do this. Maximum value minus the minimum value. Okay, so in this case you're going to obtain 14. If you do this properly, you're going to obtain a 14, and it's facing downwards. That's 14 kilonewtons. Okay, and it's point C. All right, then C, this is it at C here. From the C to D, there's a distributed. Remember, there's a distributed here in between these 2 points, and we calculated this one. It was 5 kilonewton per meter between C and D. There's a distributed of 5 kilonewton per meter. So you're just going to indicate this, a distributed load for a distance. What is the distance there? From C and D, between C and D, there's a distance of what? Of 3 meters. Sorry, we use the 3 meters here. This one was for this one. I was indicate this 3 meters is for this one, this one. Okay, we indicated this when we are calculating this. Okay, so we are going to apply this for this 3 meters. Okay, so that means it's going to be at this point, yeah, it's just 3 meters like this. Or you can just indicate it on top, but you know that there's a distance of what? Of 3 meters in between here. And that's just indicate. Don't indicate like a vertical like this, just indicate with an arrow to show that this is 5 kilonewton per meter at this point. Okay, that is what you're going to have for these 3 meters. Okay, then D, remember D is a support. So remember at point D we are now going to have our support. From the information that we did from the first part here, we said the support was at A and at D. So D is a support, so which means we shall have a support at D like this. After the distributed, then we have got a support at D like this. So this is a support at D. But what is going to happen? We need the force at D. We calculated this before, so which means it's no problem. We're just going to write it at D. We calculated this before here, so I'm going to just write it 64, this was 64,687 kilonewtons. Okay, so it's an advantage for this one. All right, then I move on to another one, which is after this D. As you can see, we moved a distance of 4 meters from this point up to this point. We moved a distance of 4 meters. Okay, so 4 meters, which is like this, a distance of 4 meters. All right, in between. And this point at E is 0. This 0 here is not at this point, it's at this point here. That's where we have 0 kilonewton. So which means if this is 0, it means at this point we moved 30, because this is 30. From this point up to this point is 30. So from this point up to this point is 30. So this is 30. For you to move to have a 0, it means you subtracted 30 at this point. Remember what you're just doing: the upper value minus the lower value, the upper value minus lower value, the upper value minus lower value. So it's the same thing. At this point is 30, so it's 30 minus 0 at this point. So you're going to obtain what? A 30, because this is a horizontal line. So if this is 30, it means also this point is 30, just like what we did here. If this is minus 5,687, this is also minus 5,687, because it's a horizontal line, it's a straight line. So it's the same thing. So 30 minus 0 is what? Is 30. But it's going downwards because it's not a support, and it's at the end of the line. So it's going to be at the end also of what? Of the beam, like this. So this is what you're going to have after a distance of what? Of 4 meters at point E. And this is 30 kilonewton, like this. Guys, take note, these broken lines are just indicating to show this corresponds to, this corresponds to, but the normal part is indicated by these arrows and being horizontal or being fixed. So these should be vertical lines, these ones vertical lines, same with other lines. Okay, so sorry for that. So that is the indication that you're supposed to be having in this case, like this. All right, so as you can see, that's how they ask these questions, guys, and there's moments and 12 marks for that. So this one is a question to stretch you further. So that's